So chapter 6, we're going to be heading back towards some trigonometry. So in class, I handed everyone this like half sheet. It's got our unit circle with radians and degrees. It's got our 1, 2, 3, 3, 2, 1 chart. And then at the very bottom, it's got, just our unit circle. We're talking about angles that are on the axis. And then just kind of reminding us about kind of like how we, lots of stuff here. And I've already assessed you on all of this stuff. So you can use this on everything. It's going to save you a little bit of time, a little bit of brain power, because I know you know how to do it. Just having it in front of you will make things a little bit quicker. So I'll probably reference this a lot today. So today we're going to start chapter 6 with solving trig equations. I mean, we actually have already solved some basic trig equations. We've been solving equations forever. We understand that some equations have no solutions, some have one solution, some have like 8 solutions or 3 solutions, or maybe an infinite number of solutions. Okay. So today we're going to talk about trig equations and what makes them a little bit different from some of the other equations that we've already solved. So let's just jump right on in here. So it says, how can we use the graph of y equals the sine of x to solve the equation sine of x equals 1/2? So I'm just going to jot this down right here. Y equals the sine of x, and I'm going to go in and draw this. The sine curve starts at 0, and at pi halves it's up at 1. Look at the scale there. Look, I went up 2 boxes. Pi, it's back at 0, 3 pi over 2, it's down at -1, and 2 pi, it's back on the midline. So there's one complete period of sine, and I'm just, because I have the graph paper, I'm just going to draw another one. So we're asked, how do we use this graph to solve the equation sine of x equals 1/2? So I'm just going to flip this around and write 1/2 equals the sine of x. And do you notice how we just replaced the y with a 1/2? So I'm really asking, for what values of x does y equal 1/2? So I just drew in the line y equals 1/2. We already have the graph y equals the sine of x. I just want to know when they're equal to each other, right? So that happens here, and here, and here, and here. So on this graph paper, I see 4 solutions. And the question is, what are the solutions? Now, it's kind of difficult to like just look at the graph. I'm going to grab a thinner pen here and find this x value. I'm like, I don't know. Like same thing here, like I don't know what that x is. But what we do know is that we can use what we already know about sine, and we can use this chart here. So I'm going to pull this paper out and say, okay, look, when does sine equal 1/2? Well, that's going to happen at pi over 6 angles, right? So we're kind of using like some old stuff. So well, let's go back here. Here it is. Sine of x equals 1/2. This is a positive 1/2. And we know that sine is positive in quadrants 1 and 2. I'm going, okay, so I'm looking in quadrants 1 and 2, and I'm looking for those pi over 6 angles. So there they are, pi over 6 and 5 pi over 6. So there's my 2 answers. Well, there's these first 2. So x equals pi over 6 and 5 pi over 6. Those are those 2 right there. But I want to go find these other 2. So I'm going to grab an orange pen here. And I'm going to connect this point to this point. And I'll grab a green pen. And I think you'll see why. I'm going to connect this point to this point. Why did I do that? Because when you look at one period of the graph, these orange points, they're the first ones I come to. And when I look at these, they're the second one I come to, but they're the same distance apart. In fact, we know the period of the graph is 2 pi, so we know those points should be 2 pi units away from each other. So if I want to go find the name of this angle, I'm going to take this one, which is pi over 6, and I'm going to subtract 2 pi. Pi over 6 minus 2 pi is negative 11 pi over 6. I'm going to do the same thing here. If this is 5 pi over 6 and I want to go back to this one, I'm going to subtract 2 pi over 6, 2 pi, sorry, to get negative 7 pi over 6. So I subtracted 2 pi to get these two answers. And I don't want to spend a lot of time on that, but we can find a common denominator and whatever. Okay. We could have been given different graph paper, and perhaps we were going to go look for more answers over here. Then instead of subtracting 2 pi, I'd want to add 2 pi to get answers that live over here. Okay. All right, we'll come back to that thought in just a minute. So it says, remembering that the graph of sine of x is a periodic function, use your graphing calculator to graph a sine curve from negative 8 pi to 8 pi. So I'm doing that right now. I'm grabbing my TI-84. I just picked this calculator. I want to make sure I'm in radians. And then I'm going to make that window go from negative 8 pi to positive 8 pi. And you know what I'm going to do? I'm going to go ahead and just change the y's to go from like negative 2 to 2. Okay, so there's my sine graph. Just a lot more of the same graph than what we saw on the previous slide. I'm also going to go to my y equals and graph that line, that y equals 1/2. Whew, look how many. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16 solutions just by changing the window. I mean, it's the same equation. I just changed the window. And so here's the thing. We know that this graph goes on forever, and I could change the window to go from like negative 20 pi to 20 pi or negative 3,000 to 3,000. There are going to be an infinite number of solutions if I look at the whole thing, right? This graph lives from negative infinity to infinity. It doesn't stop, which means if we want to list all the solutions, there's an infinite number of solutions. We'd be sitting here forever for the rest of our lives trying to write them all down. We're not going to do it that way. That's why my question is, how can we write all of the solutions without physically writing all the solutions? So we kind of already know what to do. Remember back here I said if you want to take this point and go back here, you'd subtract 2 pi. And if you want to find a point over here, you could add 2 pi. Well, couldn't I just keep doing that? Add 2 pi, add 2 pi, add 2 pi, or subtract 2 pi, subtract 2 pi, subtract 2 pi. So here's what we're going to do. We're going to take what we call the primary solutions, which are the ones in the unit circle, the ones that we got off of my orange cardstock. And I wrote them vertically for a reason. Because what we want to do, actually I'm going to grab my orange cardstock, is we know one of the answers is here. But what if I take a lap around, and then take another lap around, and then take another lap around? What if I took 25 laps? This angle would have a different name, it'd be in the same place. Or I could go backwards 1 lap, 5 laps, 100 laps. So the way we're going to write that is we're going to say plus 2 pi times n, where n is any integer. Remember, integers are positive or negative whole numbers like negative 3, negative 2, negative 1, 0, 1, 2, 3. Basically, that's saying go backwards 3 laps, go backwards 2 laps, go backwards 1 lap, or go forwards a lap, go forwards 2 laps. So we're going to do that to both answers. So I'm going to take my primary solutions, the ones that I got from my cardstock, and I'm just going to tack on this take a lap around, and the way we write that is to add 2 pi times n, where n is any integer. Okay? That's new. I mean, this is not new. Tacking this on to represent all of the solutions, that's new. All right, so this one says, let's solve a different equation over the interval negative 2 pi to 2 pi. This is using graphs, and there's a couple of ways we can use graphs. But listen, when we were back here and we said sine of x equals 1/2, we drew a sine graph and then we drew the line 1/2. We can do the same thing here. I can move that 2 to the other side. So I can take my sine graph. Now watch, I changed the scale on the y-axis. Remember, a sine graph only goes up to 1. And I've changed that, so watch your graph there. So I'm going to draw my sine graph from negative 2 pi to positive 2 pi. And I'm going to go graph the line y equals negative 2. So instead of drawing the line y equals 1/2, I drew the line y equals negative 2. Well, that's never going to happen, isn't it? right? There's no place on the sine graph where the y-coordinate's equal to -2. So I don't care what interval I asked you to look at, this equation has no solution. Right? So sometimes we'll have an infinite number of solutions, sometimes we'll have 4 solutions, sometimes we'll have 16 solutions, sometimes we'll have no solutions, right? So what we're starting to see is it really matters how the question is written and what the equation is that'll dictate how many answers we give and how we write those answers. Okay. So listen, I mean, we've been graphing to solve, but we didn't actually really solve using the graph, right? We're going to move away from graphs. I'm going to flip back here for a second. The graph was helpful in getting us to understand how many solutions, but did I use the graph to get these? No. I used my 1, 2, 3, 3, 2, 1 chart to find these. The graph did not help me with these, okay? So that's what we're going to go back to. We're going to use kind of the unit circle concept, or that 1, 2, 3, 3, 2, 1 chart to solve these. We just need to consider the fact, let's think about the graph so that we understand how many solutions we have, okay? So here's what I mean by that. We want to solve this equation on the interval 0 to 2 pi. Now, I honestly wish I had written it like this. This is what we're going to see most often, is a bracket with the 0 and a parenthesis with the 2 pi. Because we know 2 pi is really the same as 0, so it's kind of redundant to include both. Okay, so either way, let's divide both sides by 2 and write the cosine of x equals negative radical 2 over 2. A graph is not going to help me here, right? So I'm going to grab my cardstock. I know that cosine will be equal to radical 2 over 2 at pi over 4 angles. So I'm going to start with that. This right here tells me that my answers are going to be something to do with pi over 4. Now, the negative out in front, remember, oh geez, I'm going to squeeze this in here somehow. There we go. Not all students take calculus. Tells us that cosine is positive here, everything is positive here, which means cosine will be negative in quadrants 2 and 3. That's important, because that's really what we need. Okay, so we're looking for the pi over 4 angles that are in quadrants 2 and 3. All right, great. Just look at your picture. 3 pi over 4, 5 pi over 4. There's my answers. X equals 3 pi over 4, x equals 5 pi over 4. I don't need a graph to do that. A graph wouldn't have helped me anyways. Okay, so those are the 2 answers I should get if I'm just looking at one rotation of the unit circle. Now, what if we were asked to find all solutions, or I phrased it and said find the complete solution? Now, it doesn't say from 0 to 2 pi, it is implied that we want the answers from negative infinity to infinity, okay? Which means there's an infinite number of solutions. Well, it doesn't change the amount of work we did. We're just going to take our old answers, x equals 3 pi over 4 and x equals 5 pi over 4, and we're just going to tack on a 2 pi n to both. Small adjustment. This is 2 solutions. This is billions of solutions. Okay? I mean, that's even an understatement, right? Way more than that. Okay? So here's the thing. When you solve a trig equation, our goal is to solve for x, right? Get x by itself or figure out what x works. However, what we need to remember with trig equations is that sometimes we'll have an infinite number of solutions, sometimes we'll have 1 solution, sometimes we'll have no solutions. But we need to really pay attention to the domain in order to understand which answers we're going to give, okay? Other than that, nothing else in here is new. It's just kind of like an additional example, okay? All right, so let's find all solutions. And I said radian because there's nothing else in there telling us otherwise. All right, so radians, but they didn't say 0 to 2 pi because, okay, well, if they want all, that means they're asking us to look everywhere. So First thing I'm going to do is isolate that trig function. So I'm going to subtract the 2. And then I'm going to divide by 5. Okay, so sine of x equals 0. I'm going to start by looking just in the unit circle. Now I'm not up here because there's no zeros in here, right? So we go back down here now and we're going, okay, listen. I find the sine of an angle by looking at the y-coordinate. So I'm really looking, when is the y-coordinate 0? And that happens here and here. So that would be 0 and pi, right? 0 and pi. So I'm going to write those down. Those are my primary solutions. X equals 0 and x equals pi. So that's 2 solutions. I want to look everywhere. So at the very minimal, and I'm going to explain this in a minute, I'm just going to tack a 2 pi n onto both answers. That's not the most concise way to write this particular answer, and I'm going to talk about that in a minute. But in general, we take our primary solutions and we tack on a 2 pi n to both. I'm going to write down an alternate way to write all of these, maybe a little more compactly. I'm going to write x equals 0 plus pi n. Now, that's kind of like, I don't want to call it a challenge, but that's kind of like going a little bit above and beyond. This is great. This is excellent, but they represent the same thing. Why did I do this here and not anywhere else today? Because my answers are evenly spaced. I'm saying I have an answer here and an answer here, and can we all agree that the distance or the kind of the angle between them is the same? So instead of saying go here and then take a lap and take a lap and take a lap and then go here and take a lap, I can just as easily start here and take half of a lap, and that gets me here. And then take half of a lap, and that gets me here. And then take another half. So this is a more compact way to write this. I'll let that stew with you a little bit. You don't have to do that. But that's it. Now let's take a look at this one. First thing I'm going to do is realize that when they say tangent squared of x, that really means the tangent of x squared. So maybe I do it that way first. Great, let's combine like terms. Let's move that 4 to the other side with some subtraction. And then let's take the square root of both sides. And we know that when we take the square root of both sides, we need a plus or minus. All right, well, I'm going to grab my orange paper here. I really want to know, when is tangent equal to radical 3? So tangent is equal to radical 3 at pi over 3 angles. So let me grab my red here. So this tells me I'm looking for the pi over 3 angles. The plus or minus says you can be positive or negative. That means I can be in all 4 quadrants, which means I'm going to have 4 primary answers. So I'm going to grab my orange paper again. I'm looking for the pi over 3 angles in all 4 quadrants. 1 pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So that's what I'm going to write down. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Those are my primary solutions. And I'm just going to tack on a 2 pi n to every single one of those to get all of my solutions. Is there a better way to write it? Yes, I'm going to throw it out there just for those of you that are interested. I'm going to write x equals pi over 3 plus pi n. X equals 2 pi over 3 plus pi n. Again, that's kind of going above and beyond and being a little more concise. They mean the same thing. I'm going to guess most of you are going to go with just this because it requires less brain power, which is fine. It's not wrong. But I'm encouraging you to look at something like this. Okay. All right, I'd like to finish up with just kind of a little review on our graphing calculators here. Okay. So, it's kind of how we started class a little bit today. Use a graphing calculator to find the solutions to this equation on the interval 0 to 2 pi. All right, well, again, we could, just like we did, we could graph this, not by hand, And we could graph this and find their intersections, but you know what, and you know this about me, my preference is that we set this thing equal to 0 so that I only have to draw one graph. So we're going to go graph this, and because it says equals 0, we're going to go find the zeros or the x-intercept. So I'm going to do it on an 84. I know we've done this before on both calculators. So this is I mean, not really review of the calculator, but what is review of the calculator, sorry. So I've got 2 cosine of x plus 3, close your x plus 3, and I'm going to subtract 0.35. My window is not the window I want. I want to go from 0 to 2 pi. And I'm looking for x-intercepts. I see 2 of them. So I'm going to hit second trace. I'm going to go down to number 0. And this one looks somewhere between 1 and 3. So I'm going to put in a 1 for my left bound and a 3 for my right bound. And when it says guess, I'm going to hit enter. So one of my solutions is 1.888. I'm going to do the same thing again. I hit second trace. I went down to number 2. This one is between 1, 2, 3, like 4 and 5 or 4 and 6. So I'm going to type in a 4. Then I'm going to type in a 6 or a 5 and hit enter. And it jumps to my second answer, which is x equals 4.678. Okay, there's my 2 answers. Now, let's look and see what changes here. Now find the solutions to the same equation on a different interval. So now I want to spit out answers between -6 and 3. By the way, doesn't this one fall in that interval? This one doesn't. Right? That's bigger than 3, but I think we already have one. Now I'm going to go change my window, but that's all I need to change. So my window, I'm going to look from -6 to 3. So I have 1 0, 2 zeros, 3, and that's the one we already have, isn't it? Right? So don't double down on the amount of work. If the equation stays the same and this is still in that interval, well, there's one of my answers. But now I have 2 new ones to go find. So this one, let's see, -1, -2, -3, is somewhere between -5 and -4. And when it says guess, I'm just going to hit enter. So I have -4.395. I'm rounding the nearest thousandth. And I'll go find the next one, which is somewhere between -2 and -1, or -3 and -1. You just need to give kind of a general vicinity, and it's -1.605. So, what I want to kind of remind you of, and we've talked about this along the way, the interval over which we're solving can change how many solutions we're finding. And when you're using a calculator to solve an equation, my favorite method is to move that to the other side so that we just have to find x-intercepts.